Well, good evening, everyone. Can you guys hear me?
Yes, good evening.
Good evening. Um, well, so far we have 8 students. I think we have a lot of students are in this class. Hopefully they will join us in a few minutes. Let me just make sure how many students we have in this class. Yep, definitely more than 8. 14 students. Anyway, today we're going to start a new module, which is module 4. And in module 4, we're going to talk about branches. Branches is one of the most important concepts in programming. We're going to see what it is, what does it mean, how do we use it, and the tools that we need to know and to master to be able to use branches concept. So what I'm going to be doing, I am going to use Visual Studio today to demonstrate the concept in general. And I'll be switching on and off between Visual Studio, of course, and the ZUI books. So let's start with the definition of branches. What is a branches? Well, before we get to the branches, let's talk about something called the normal flow of execution. So what is the normal flow of execution? The normal flow of execution is simply means when you have a program and that program, for example, contain those 3 lines. Yeah, for example, x plus y and line semicolon. So let's look at this program. We know that when the program is when you start executing any program, you're going to start from the main function. And this will be my first line to be executed. And then this is going to be the second line, and this is going to be the third line, and this is going to be the fourth line, and this is going to be the fifth line. As you can see here, when the program is going to be executed, the compiler is going to follow specific way or specific method of executing these lines. And that method is you start with the first line, you finish executing the first line, you move to the second line. You finish executing the second line, you move to the third line. You finish executing the third line, you move to the fourth line and the fifth line until you're done with the main function. And that's what we call the normal flow. The normal flow basically means you can execute those instructions of that program one by one based on their order that you typed. And that's why I see a lot of students sometimes they get some errors because they don't follow the logic order of the execution. You need to understand, for example, I am not going to be able, if I take this, for example, and put it at the top here, immediately I'll get error. Why am I getting errors here? Because the compiler follow the normal flow of execution. As you can see here, we start executing from this line. And of course, when you start from this line, the compiler will immediately be hit with X and Y, and the compiler doesn't know what is X and Y. So the order here is very, very important. But again, this is not what this class is all about. I'm just showing you what do we mean by the normal flow of execution. Now, in programming in general, we sometimes want to control this normal flow of execution. For example, what if I have one line that I want it to be repeated for 5 times or 10 times or 100 times or a million of times? That's again what we mean by branch. It basically means one instruction or a group of instructions that I want to control how, or the program I want to control how they're going to be executed. And that's what we mean by branches. Now, today, it's all about selection branches or selection structures. Next module is going to be about repeating structures. So I'm not going to talk about repeating structures today. My focus is going to be selection structures. Now that we know what is a normal flow, let's ask this question. Why do we need programs in general? Well, one of the main applications that we actually use programs for is making decisions. You basically want to have a system that can make some fast, reliable decisions for you when, for example, you cannot make that call for any reason. I'll give you an example here. Now, these days, cars are computerized. There is a computer in every single car. And modern cars, basically, when they notice that there's an object in the front of the car will immediately stop. This is, again, a life and death situation where you have a car. Inside that car, there's a computer, and that computer need to make a decision that will be the difference between having an accident or surviving an accident. So this is how important the capability of your program to make a decision. Should I continue driving the car, or should I just immediately stop the car? That's what we mean by making decision. Artificial intelligence, which is a really, really big deal these days. It's all about decisions. How can I make my computer make a decision? How can I make my computer realize that this is an apple, it's not a ball? How can I make my computer to be able to diagnose a cancer, for example, in an image, or diagnose something else? So the fact that we can actually have a program, and that program can actually make a decision or can detect something, that's a really, really important application. And all of that will be done using what we call selection structures. And this is the chapter which is all about selection structures. Now, of course, in today's class, we're just going to talk about the basics. How do we actually control that thing? But in reality, if you're going to go further in this study, if you're going to go postgraduate studies, you will see how important, how powerful the tools that we're going to talk about today and how helpful they are. I remember in my PhD, for example, we made a system that was able to detect if a patient has a cancer or not, based on CAT scan images, around 300 CAT scan images. We actually take them, we extract the organs, and then we build the organs in a 3D modules. And then after that, we study the tissues of that organ. And then after that, we were able to tell if that patient has a cancer or not. How did the computer basically was able to do that? It's basically a very, very complicated, I will say, I'm not going to say simple, complicated selection structure that we actually built for the system to be able to tell if that patient has a cancer or not. So what I'm trying to say here today is selection structures is one of the fundamentals and most important operations that you can actually use to make your computer being able to make a decision or came up with a conclusion. I would do something. So how is that possible? Well, the idea for selection structure is very simple, and I'm going to just explain it here. At a certain point in your program, you're going to have a test. You're going to test something, okay? And then depending on the result of the test, if the results of that test comes, I would say positive, well, in reality, we call it true or false. If you tested something and then the result of that test comes positive or true, then you basically will be doing something. Now, we do have another branch or another type of selection structures we're going to talk about, but let's just focus on the first type here. I'm going to test something. And then if the test that I applied here will give me a result of true, then I'll be doing something. Otherwise, if the test result came false, I'm just going to go normally with the rest of the program. This here is what we call the basic type of selection structures, which is basically a basic if statement. Now, I'm going to talk about the details of those if statements, and then we're going to move on to the if else statement. So what is this if statement? And let me just show you an example here so you will have an idea. Now, imagine we have an integer. I'll call it num. And let's imagine that num is 100 and negative 150. Now, imagine I want to convert, I want to get the absolute value of num. Remember here, num is a negative value. So what if I need the absolute value of num? Well, here's what I can do. I can come here and say num multiply equal -1. Let's go ahead and show that on the screen. Num1 or num and line semicolon. Okay. Now, I don't want to run it, but I'm going to tell you now. If I execute this program, since this is -150, and this line here is equivalent to num equal num multiplied by -1. So since negative multiplied by negative is going to be positive, so I'm going to get positive 150 printed on the screen. Let me just run it. I think let me just share the screen again. As you can see here, it's positive 150. Okay, so let's go back to the program. And now the question is, what if it was positive? Remember here, the absolute value of a negative value is a positive value, and the absolute value of a positive value should be positive value. But based on this methodology that you see here, I'm actually going to convert this from positive to negative, which basically is the opposite of what I want. So here's what we can do. I can use an if statement, a very simple if statement, and here's how it works. As I said, with if statements, usually we are kind of doing a test before we decide what we're going to be doing. Or basically we could think about it or look at it as we're testing something, or we're asking a question. So let's go ahead and do that. The if statements syntax start with the keyword if, and then you open a parenthesis and you close it. This is very important. Now, between those parentheses, you can have to have expression. The most important part about that expression, it should give you a result of true or false. Now, we'll see that that's not the case always. You can have expressions where the result is not true and false, but the compiler will find a way to decide if it's true or false. But again, we're going to talk about that later. Here's what I can do. I can come here and say, if num was less than 0. Remember here, this here is my number. This is my if statement. This is what we call a Boolean expression. I'm going to talk about Boolean expressions in a sec, but this is my Boolean expression. And this Boolean expression, I'm asking this question. Is num less than 0? And when you say num is less than 0, basically you're asking, is it negative value? The question is, well, again, if this expression is evaluated as true, then basically, this is what I'm going to do. I'm going to open a curly brace here, and I'm going to close it. And this is what we call the body of that if statement. Now, the body of this if statement is basically what I'm saying. If it happened that num was less than 150, less than 0, which basically is negative value, then I'm going to multiply it by -1 to convert it to a positive value. And then I'm going to show it on the screen. Now, the question here, let's just put here, if I have -150, that basically means this expression is going to be true because -150 is less than 0. So this is going to be executed. Now, what if it's positive 150? That basically means this statement is going to be false. And because it's false, the compiler will ignore this part and jump and continue with execution to show me the positive value. Now, this is a very simple example of an if statement. And what's important here to know that this is the normal flow of executions. Line 1, line 2. Now, line 2, since it's a selection structure, the results of the evaluation of these expressions will determine if I'm going to actually execute this one or I'm going to skip it. In this case, since this is positive, so this is false, so the compiler is going to skip the body of the loop and continue normally. But if it happens that this value was negative, so that basically means this is going to be true in that case, so the compiler will actually execute this line and then it's going to go back to the normal execution. And that's what we mean by the if statement. Now, let me just run it 2 times so you'll see the results. I'm cancel. What I'm going to be doing, so you guys can see this 2 times, I'm going to put num1 here, num1 here, num1 here, num1 here. Let me copy this and put it here. This time I'm going to put num2, 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 num2. This time I'm going to put this as positive. Okay, so you would notice that either way, I'm going to get the right number printed as a, sorry, I'm going to get a positive 150. And let me share my screen. And here it is, 150 and 150. Okay, let's go back to Visual Studio. And let me close this. Okay, now let's take this away for now, and let's talk about this expression here. This is what we call a Boolean expression. And to create a Boolean expression, basically you need what we call a comparison or relational operator, which is in this case, I'm using less than. We do have a list of operators. And those relational operators, we have less than, we have greater than, we have less than or equal, we have a greater than or equal, and we have equal, we have not equal. So I can use any of those 6 operations instead of this one, okay? And what you need to do, you need to have 2 operands on both sides, left side and the right side, and you're basically going to be comparing the left side to the right side, and based on the relational operator here, you're going to come up with a conclusion if this relation or this Boolean expression is true or false. And that's how important, and this is how it works. Now, before I continue, let me just show you a few mistakes that a lot of students fall into when it comes to Boolean expressions. Mistake number 1, or before I move into mistakes, let me just show you 2 points. Point number 1, since this here is a single statement, I can take this curly brace away. That will work perfectly fine, even though I don't recommend do that for beginners. Always have an opening and closing. Why I said I don't recommend this for beginners, because sometimes you forget that you have more than something. Again, what I'm saying here is, if you have multiple statements here, then you don't have other choices but having those curly braces. But if it's a single statement like the one that I have here, you can totally take those away. But again, we're learning for the first time about this, so I recommend to keep them here. So that will be number 1. Number 2, I see a lot of students, they put a semicolon here. That will ruin everything. Okay, even though he's not complaining about anything, but that basically will ruin everything. So don't put a semicolon here. And you may ask a question, what if I put a semicolon here? If you put a semicolon here, basically you're telling the compiler that this is the end of the if statement, doesn't have any body. So this line is going to be executed whether this one is true or false. So that's another error that I see a lot of students do. Now, a lot of students make mistakes when they actually come here and try to use the equal assignment, equality operator. Now remember here, if I put something like this, I am comparing num1 to 0. And since num1 is negative 150, so that basically means this expression is going to be false. Okay? This is something you have to understand. Now, a lot of students do the following. They forget to put double equal and they put a single equal. Now, let me tell you what's going to happen here. This expression by itself, there's nothing wrong with it. The compiler will take 0 and assign it to num1. And basically, num1, which was negative 150, now it's going to be equal 0. Now, the compiler will look at the whole operation as true, because the compiler was able to successfully assign 0 to num1, and that is good enough for the compiler to consider and evaluate the whole operation as true. I was able to assign 0 to num, I'll take that as true. So sometimes you actually put an expression here like this one, you in your head, you're thinking you're comparing negative 150 with 0. So you see this is supposed to be false, but no, for the compiler, you're not comparing, you're actually assigning 0 to num1, and that's good enough for the compiler to treat the whole expression as true. So always pay attention to double equal here versus single equal. Okay, so this here is a very simple example of what we call a Boolean expression with an if statement. And this is a very simple if statement. Now, let me just explain something here, very important. And let me go back to my original example, which is this case. Now, as I said before, this is a case where I'm only concerned if the value is negative and I want to convert it to a positive. Okay, so if it's negative, I'm going to convert it to a positive, but if it's positive, then there's no need for any converting. So this is basically why I'm having this simple if statement. So the whole situation that I have here is I am only concerned if this statement is true. If it's false, I'm just going to go normally with no problems. Now the question is, what if I need to have a scenario if the expression was true and a different scenario if the expression was false? And I'll give you an example about that. Let me see here. I'm looking here to see it. Now imagine you have a business and you are trying to rent a room, for example. Okay, now if the person who's trying to rent a room is, let's say, older than 65, you will give him a discount. And if the person was younger than 65, he will just pay a regular rent. So here's what I'm going to do. So you see here, in this case, I was only concerned with when this situation here or this expression is true. So I'm going to evaluate, run this statement here. But if it's false, that basically means the number is already positive. So there's no need for me to do anything. I'll continue here. Now I have a different scenario here, and I'm going to show you two examples about that now. The first one, if I have, for example, an integer, I'll call it age. And I will have, let's say, an integer days. So I have days that's going to be, and I will have, let's say, an integer, I'll say rate. Okay, you know, I'll keep the rate not assigned. So I'll just keep it here. Or you know what? Rent, for example. We'll just keep the rent here. Now, imagine that person is 80 years old and he want to stay for, say, 7 days. So here's what we're going to do. We're going to come here and say if, look at this, the age was greater or equal 65. So we're asking the person, how old are you? And he said something. So we're going to have to go and test it if he is greater or equal 65. So rent in this case, for example, will be the days, which is 7 in this case, multiplied by the rent. Well, the rate, let's imagine the rate for this case will be $100. Okay, so here we go. This is my rate for senior citizens. Now the question is, what if he was younger than 65? So look what I'm going to do. I'm going to come here and use a keyword called else. Now, before I say anything about the else statement here, I just want to show you what's the difference between this one and this one. In this scenario case here, I was only concerned if the number was negative. So I'm going to convert it to positive. But if the number was positive, I don't need to do anything. I'm just going to continue normally. Now here, I have two situations. The first situation, if I have a senior citizen, so I'm going to calculate the rent in a different way. And I have a case where if we don't have a senior citizen here, we have a young person. So the rent in this case will equal, for example, days, but multiply, for example, 150. So you can see here, I do have an if statement. I have a Boolean expression here. If this expression was true, something's going to happen. But if it's false, something else is going to happen. And then let's go ahead and show the rent and line semicolon. So this here summarize the main difference between the if statement and the if else statement. The if statement is basically, and again, there is no rules here. You need to know the syntax. You need to know how does it work. And then depending on the problem you're trying to solve, you need to be able to tell by yourself, do I need an if? Do I need an if else? Do I need a nested if statement? Do I need a switch? Do I have a conditional operator? We have a long list of options, but the right option, there is no magic rule that will tell you you have to use this in this case. It's all up to you. You're the one who's studying the problem. You know, you're the one who's supposed to know if this is a simple case of an if statement or an if else statement, or again, whatever we're going to be covering later. I'm going to show you another example here. For example, integer, we have hours. We have integer pay rate. Let's say we pay $10. Let's say he worked for 35 hours. And then I will say another integer, we'll call it double this time. And this time I will say payment. Okay, I don't know how much is payment. I'm going to check this to be a double as well. Let's put 10.0. Okay, now this is a case where I'm supposed to calculate the payment of a worker. Now we know if a worker worked for less than 40 hours a week, then he will get paid normal pay. But if he works more than 40 hours a day, then we have to pay him extra for the extra hours he worked with a different pay rate. So imagine you will get paid at a pay rate equal whatever the regular pay rate plus half of it. So basically what I mean here, you're going to be paid $15 for the extra hours. So let's go ahead and do this. I will say if hours was greater or, less or equal 40. So you worked within the regular hours. I will say payment equal hours multiplied by pay rate. That's how simple it is. Now the question is, what if you worked more than 40 hours? Okay, so here's what we're going to do. We're going to come here and say payment is going to equal. First of all, I'm going to multiply 40 by pay rate. So for the first 40 hours, you will get paid using the regular pay rate. Now, in this area here, I need to calculate how much extra hours did you work. For example, if you worked 45, you have 5 hours extra. So I'm going to come here and say hours minus 40. So I can find out how much hours extra did you work. This is all going to be multiplied by the pay rate plus half of it, which basically means pay rate divided by 2, for example. And this is supposed to be lowercase. So basically what I mean here, I mean your extra 5 hours, for example, imagining he worked 45 hours, is going to be multiplied by the regular pay rate plus the extra half. So basically this is 10, this is going to be half of 10, which is 5. So the total pay rate is going to be 15 for the extra 5 hours that you worked. And then after that, see out, I'll say payment. So here we go. This is another example where it is a big deal if this statement here is true, and it's also a big deal if it's false. If it's true, I'm going to calculate the payment using this technique. If it's false, I'm going to calculate the payment using different techniques. And that's another example of the if-else statement. Now, as I'm going, I'm just checking in my screen, the ZY book, to make sure that I'm not missing anything. There's a lot of examples, by the way, in the ZY books. You guys can have a look at it. But this is mostly what we need to know about if statements. And let's keep going. Now, the question is, as you can see here, I have a case where if this is true, I'm going to do something. And if it's false, I'm going to be doing something else. Now, what I'm going to be doing now, I'm going to focus on this Boolean expression. This Boolean expression by itself it's a very simple Boolean expression. In reality, Boolean expressions are a little bit more complicated than just a simple two operands separated with a very simple a relational or comparison operator. We have what we call logical operators as well. The logical operators are basically what we call and, or, and not. Now, we use those two logical operators to combine more than one simple Boolean expression. This not operator is basically used to reverse the results of the Boolean expressions. And I'm going to talk about them in details in a sec. So let's start with a simple one, the not, which again, let me just say something here. Even though we do have not operator, but it's recommended not to use it a lot. If you can avoid using not operator, it's a good idea to do that. Why? Because using not will only add a level of confusing to the expression that you have. So it's always recommended not to use it. So let me show you an expression here. I'll say cout. Oh, and before I continue, C++ interpret true as 1 and interpret false as 0. Okay, so let me put this here. 10 equal 10. End line. Let's look at this statement. I'm comparing 10 to 10, and I'm using the equal operator. So that basically this is going to be true. Okay. And if I run it, I'm just going to run it. And I want you to focus on the last line in the results. Oh, wait a minute. I didn't show it on the screen. It's not showing it on the screen. For some reason, it didn't show it. It should be able to show it. For some reason, you're not doing it. We'll just come here and create two variables. Integer x1 equal 10, x2 equal 10. Put semicolon here. Let's compare x1 to x2. Let me try run it again. Oh, that's weird. It's not showing this. What am I missing here? Anyway, let me just do a different one. This is weird. It should show me a 1 printed on the screen, but for some reason it's not doing this. Let me try here. If I say BOL Boolean answer equal x1 double equal x2, put semicolon here, and I will say show me answer. Let me run it again. Oh, I made a mistake. I'm supposed to take this one, put it here. This is what I was talking about, the order of the operations. Now, let me just go back and put it the way it was. It was my mistake. Let me take this away. Let me run it again. Okay, let me show you the results. I want you to focus here on this one here. As you can see, x1 and x2, they're exactly the same. So I got 1 printed on screen. Let's share the screen here. Now, if I just come here and put not, okay, this will flip the result of the suppression and put it as 0 instead of 1. Now, it's very important to understand that you have to put the parentheses here, okay? If you don't do that, you put it this way, you probably will get errors, okay? This not is supposed to be associated with the Boolean expression. Now, it's just trying to be not to the x1, not the whole expression, and that's why you're getting an error here. So it's recommended here to, not recommended, it's actually something you have to, if you want to use the not, to put the parentheses here to flip the result of this expression. Now, if I run it, and let me show you, I got 0 here. Okay. Now, this is the not operator, which again, as I said, It's something you should avoid using as much as possible. Now let's look at this and this or operators. This and this or operators are used to combine multiple statements. And the results that you have to follow here, let me just jump straight to the logical operator. So I'll show you the table. And where is it? Okay, let me share my screen. And here it is. So I want you to imagine the following. A by itself, it's a Boolean expression, and B, it's another Boolean expression. And the AND operator, even though I'm typing AND here, it's not AND, it's two double %. Where is it? He's not using the right. This is C++. Why is he typing AND? Here it is. Yep, that's what I was hoping to see. Anyway, so what I'm saying, this is what we call the truth table. And the truth table basically will show you the results of using and or operators. Now look here. You will get a true results for an and operator if both ands are true. See here, if A is true and B is true, you get true. Otherwise, you will always get false. As you can see, false, 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 true, false, false, true, true, you get true. Now the or operator here, and I'm pretty sure this is not old news for you, most of you guys. You will always get true unless both of the ands of the expression are false. So you got false, false, you got false. Otherwise, false, true, 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 false, true, true, true is true. So this Boolean expression table, logic table here is very important to understand whenever you have an logical and or logical or operators. So back to Visual Studio. I can mix and match multiple of those Boolean expressions depending on using logical operators. And let me show you an example right now. And of course, this expression or this example that I'm going to be using right now may not be the best way to answer the question, but I'm just going to use it for now, and then I'm going to fix it. So let's imagine you have an integer called grade, and your grade, let's say, is 87. And I want you to tell me what is this grade in terms of A, B, C, D, E, A, B, C, D, F. Here's what we can do. This is a case where we have what we call a nested if statement. So what is a nested if statement? Nested if statement basically means you're going to ask and check for one statement. For example, is this an A? So I'm going to come here and say, how do I know if a grade is an A? Well, basically, that grade should be less or equal 100, and at the same time should be greater or equal 90. So if the grade was less or equal 100, at the same time greater or equal 90, then that's an A. See out. Let's put an A here. And line. Okay, so this is my first test. Now, what do I do after that? I'll put my else. Now, the question that you have to ask yourself, is it a simple else? Like if it's not A, then it's B? No, there's more possibilities. This is what we call a nested if statement. So what I'm going to do after my else, I'm going to have to do another test. In this case, I'm going to say if, and look at this, I'm going to say if grade was less than 90, at the same time, grade was greater or equal 80. Well, that's a case of a B. So let me copy that and put a B here. So as you can see here, this is what we call a nested if statement. After your first if else statement, you start by another if statement to test for something else. So you pass the first test for an A, it's not an A, so it could be a B. Now, what if it's not a B? Well, you're going to have to test for a C. So look what I'm going to do. I'm going to say if grade was less than an 80. At the same time, grade was less, wait a minute, was less than 80, greater or equal 70. Well, you know, in that case, what do we have? We have a C. Semicolon. Now, what I'm going to do, I'm going to copy this, put it down, and I'm just going to change this to be 70. Now, remember, this is not the best way. I have an easier way. I'm going to talk about it in a sec, but I'm just showing you a demonstration of using, what did we say? This is ABCD. So if it's less than 70 and greater than 60, that's ABCD. Am I missing something here? A, B, C. And then here it is. Of course, I forgot to put my closing. Now we have the else if, and this time I'm just going to go say grade was less than 60. And that's a very simple F. F and line semicolon. Now, the last part here, which is very important, if the grade was a negative value or was greater than 100, then basically that basically means I made a mistake in the grade. I'll just say else, cout error, and line semicolon. So let's go ahead and look at this Boolean expression. It's a little bit complicated, it's a little bit long, but it's okay. I do have a grade. I want to check if it's an A or a B or a C or a D or an F. So as you can see here, the results of the, what my concern is all about, the result is not just related to true or false or simple. Yeah, it's still true or false, but I have multiple scenarios that I have to test for. I have to test if it's an A, I have to test for a B, I have to test for a C, I have to test for a D, and I have to test for an F. And also, I still have to test if the user entered a number that's not acceptable. So that's why we have what we call a nested if statement, as you can see here. Now, let's look here at this Boolean expression. As you can see here, I have a simple logical, Boolean expression here, a Boolean expression here, connected with the AND operator. Now, it's very, very important to understand that you have to come up with a decision on when to use and when to use or. I see a lot of students here making the mistakes by using or. If the number was greater than, less than 100 or greater than 90. Well, that's not how you check for a range of values, by the way. Again, I'm checking the value between 100 and, see what I'm saying, between 100 and 90. So again, I have to put and here. Okay, now this expression by itself, as you can see here, for this to be evaluated as true, both ands has to be true. So this has to be true and this has to be true for the whole expression to be evaluated as true. Now, I said something before and I said, this is not the best way to do it. And I'll show you some mistakes that I see a lot of students do. What they do, and I'm going to do it and they're going to take it back, they don't like the idea of nested if statements. So I see a lot of students, they do it this way. They take this one away, and they take this one away. And then they came here and they type an if and they put a statement just to check. Oh, for example, I'll just do it here. If grade, I'll look at this, was greater than 100 or grade was less than 0. This is a perfect case for an or statement. So I'm checking here the grade was greater than 100 or was less. That basically is it's a positive value greater than 100 or a negative value. Okay, so what's the problem with this technique? The problem with this technique basically means, let's imagine the grade was 90, 97, for example. Well, if I'm using this technique, what's going to happen? The compiler will check and see it's actually an A. So it's going to print A on the screen. But after that, it's going to check for a B. It's going to check for a C. It's going to check for a D. It's going to check for an F. And it's going to also check for a grade that is unacceptable. So you see here, even though I got the first statement here, first if statement to be true, I still have to go through all these if statements if I don't use else statement. Now, if I just come here and put else, and I'll just come here and take all this and replace it with an else, what's going to happen? The compiler will see here, okay, this statement is true, so I'm going to print A, and anything after that is going to be ignored. So your computer is basically going to skip all these and jump to system pause. Compare that with the fact that you have to go and check each one of those if statements, which consume time. So that basically why we do have the if statements here. Now, what else I should know about this statement or this expression? I said this is not the best way to do it. Here's what I can do. I can simplify this this program here by taking this part away. If the grade was less than 90. Now, why am I have to do this? Because again, look at the first expression here. I'm checking if the value was less than 100, okay, or equal 100, and greater or equal 90. So for sure, if I test this expression and it was false, then there's no need, doesn't mean anything to test if it was less than a 90. Of course it's a less than 90 because I already tested if it's greater than 90 and less than 100 and it was false. So that basically means there's no need for me to check for this one anymore because I already tested it here. So this program could be a little bit more efficient if I take those away. Now imagine this scenario here. I tested this one, it was negative, so it wasn't in this range, and I tested this one is still negative. So of course, since it's not in this range and it's not greater than 80, so of course it's going to be less than 80. So there's no need for me to check for this as well. And I can do this as well. And that's how simple this expression or program could be converted to. And this is again, how do we check for a range of values? Remember here, range of values, you have to tell me a number that's less than a number at the same time greater than the smaller number. Now here's an error that some students fall into. A lot of students get confused between math and programming, and they will say, well, I can type a grade, and I'll just say 100 and then 90. Something like that. Now this is acceptable in math. If you give me this expression in a math class, I'll take that. But if you take this one and you replace it here, it's not going to be accepted. Even though some other programming languages like Python, for example, will take this and accept it, and it's going to work for Python. I think maybe even Visual Basic will accept it, but in C++, no, you're not allowed to do that. And if you do that, you will get an error. So this is what we mean by nested if statements. This is what we mean by using logical operators. I showed you an example of using the and then later maybe we'll see some other examples. So I'm just checking now the ZY book just to make sure. Detecting a range. I showed you how do we detect a range of values. Detecting a range using if-else statement. I got that part. The logical operators, we got that part. And in the or. There's an example. I want you to go ahead and have a look at it in the book. Now, I'm going to talk about another concept related to the branch or selection structures. Now, there is a concept called short circuits. And short circuits simply means it's a technique. It's not like a syntax that you're going to have to use to improve your program, but there's something's going to be happening automatically in your code. You don't see it, but you should understand what it is. And I'm going to show you this example. Now imagine we have n1 equal 10 and 2 equal, let's say 20, and 3 equal 40 or 30. Let's put it that way. Now look what I'm going to do. I'm going to come here and say if n1 was greater or equal n2 and n2 was less than n3. Let's look at this Boolean expression. Okay, so I do have one Boolean expression here, another Boolean expression here, and they're separated with an AND operator. Now let's look at each one of those Boolean expressions. Let's look at this one here. N1 is greater than or equal N2. Now let's look at this expression. Now N1 equal 10 and 2 equal 20. That basically means this expression is false. Now let me ask you this question here. If this expression is false, does it really matter what you have in this other hand? Now we said for you to get an expression, a Boolean expressions, to be true when you have the AND operator, that basically means this AND has to be true and this AND has to be true. This is what the compiler would do. The compiler will look at the first left side of the expression and evaluate it. If the compiler found that this is false, the compiler will ignore everything after this AND operator. There is no need to waste my time checking anything here because this was false. This is what we mean by short circuits. Now let me just replace this with an OR, and let me change this relationship to less than. Let's just put it this way, less than. Now, and let me put here equal. Okay, this is another scenario here. Now let's look here. I have an OR operator, and look at this expression here. I said N1 is less than N2, which is true in this case because N1 is 10, N2 is 20. So this expression is true. Now, because this one is true, it doesn't matter what you have after the OR operator. As long as the first expression is true, that basically means the rest of the expression is going to be true. So the compiler will ignore everything you have after the OR and just focus on the first expression. This is what we mean by short circuits. Now, the question here is, what if this one was false? Well, if this one is false, the compiler will have to check this AND here because, again, it could be true or could be false. So the result totally depends on that. Same thing here. If I use AND, and I'll say N1 was less. Now, since this is true, the compiler still have to go and check the other AND to make sure if it's true or false, so the final evaluation will be found out. But usually with the AND operator, if the first expression was false, then there is no need to continue with the evaluation. The whole statement is going to be false. And whenever you have the OR operator, if the statement here is true, then there's no need to continue with the evaluation because the whole statement is going to be true as well. Okay, now, what if we have expressions that are way more complicated than the ones that I have here? For example, I can come here and say if 30 multiplied by 12 minus 100 was less than 0 and 100 equal 100 divided by 1 and I am going to come here, open another parenthesis, and I will come here and say, or 3 is greater than 100. And I'll put expression here. Again, I'm just showing you something that's acceptable by the syntax, even though it doesn't make any sense to use these numbers, but I'm just showing you an example. What if you have an expression this complicated? This is an if statement. Now, it's very important for you to understand how the compiler is going to evaluate this expression. Why is that important? Because later you're going to be writing code. And when you write a code, you need to be able, by your brain, to evaluate it the same way the compiler will evaluate it. That way, if you get unexpected results, you know that why are the results are coming from. So it's extremely important to understand how the compiler will handle expressions like that. Now, we have certain rules that we have to follow, and I'm going to show you those rules. Let me go here. Order of evaluation. Here we go. So usually the parentheses are going to be executed first. Whatever you have in parentheses, that's the first thing is going to be executed. And then after that, if you have any not operator is going to be executed after those parentheses. And then after that, if you have any arithmetic operations, multiplication, division, module, plus, equal in this order. So if you have a mix and match, you have to go in this order: multiplication, division, module, plus, equal. And then after that, if you have the relational operators, those greater than, less than, or if you have mix and match, basically, you're going to have to perform those, and then you go to the equal and not equal. And then finally, you have and you have or. And comes first. Okay? So based on this table, if I go back to my expression, I will say this has to be evaluated first, whatever you have between those two parentheses, which basically it's a simple, oh, I have a division, so this has to be evaluated first, and then it's going to be compared to 100. So the final result is going to be true. And then after that, I have an or operator with this operation. So this is going to be evaluated after this. So I get false, true and false. So the final evaluation for this is going to be true. And now after that, I have an and. So before we do the and, we have to evaluate this expression here, which basically is going to be false, I believe, or true, because it's going to be less than 0. So you got true here, you got true here. So the final evaluation for this is going to be true. It's extremely important to learn how to evaluate those expressions. In the ZY book, you have a lot of exercises here, which I highly recommend everyone to go ahead and have a look at it. Which one of these is going to be evaluated first, the and or the not? The not. This expression, basically, which operator has which one of them is going to be evaluated first? I will say the multiplication. So how about this? In which order are the operators evaluated? So let's see here. We got not equal. We got and. We got plus. We got subtraction. So it's going to be plus, subtraction, not equal, and then and. I'll say this one. Okay. And let's look here. To which does the expression evaluate given integer x and 7? So this one equals 4. This equals 7. Now, based on what I know, this is going to be evaluated first. X plus 1, so that make it 5. And then after that, we said less is going to be evaluated before this one. So I'm saying here, 5 is greater than 7, which makes it false. So this is going to be evaluated, which basically going to be false. So it's going to be false. And here we go. It's extremely important for you to understand the order on how this is going to be evaluated. I talked about this already to find the range of values. So let's go back to Visual Studio. Now, again, if you have questions at any time, please stop me. Or if you don't want to do that, write your questions on a piece of paper, and once I'm done, you can ask any question you may have. Okay, let's see here. Now, we talked about everything related to if statements. The only part left here that you should know is whenever you use those relational operators, you see them here, you can use them with any data type, primitive data type, and even with strings, you can use them with strings. We're going to talk about that later. But you should never do the following. Let me show you that. For example, I can come here and say double D1 equal 10.00. Another double D2 equal 10.00. Now, never use, let's see here, if D1 double equal D2, I'll say here another if statement, D1 not equal D2. Never never. So you are, again, the compiler is not complaining about anything, but this is not going to give you a result you expected. Okay, you can use greater than, you can use less than, but anything that has the equal sign, don't ever use it. So this basically, don't use this. Same thing here. Let me just copy this. Even though it's not that big of deal, like, let me just put it this way, greater than equal, not equal. Whenever you do it this way, you're basically ignoring this part. You're just testing for greater or less than. Now, the question is, why am I saying never use doubles to test for equality? Because this number you see here, the 10.00, in reality, it could be something like this. And this one, it could be something like this. The precision here is a big deal. You cannot guarantee the precision of two doubles to be the same. Look at this. This is 10 point, a lot of zeros until 1, and this is 10, a lot of zeros till 2. In my program, I just see it as 10.00, and this is 10.0, but the actual value stored inside the memory, it could not be just 10.00. There's a lot of numbers that you don't see in it. So testing for equality here is not a good idea. So this is something that it's worth mentioning here. Let me just check something before I continue. What do we have left? We have the switch statement, characters, strings, and then strings, conditional, floating points. I talked about that. Short circuits, I talked about that. Okay. We're doing good. Maybe I just need 15 minutes more so I can get this whole thing done. And I'll give you a break after that. Now, in most of those cases, you can think about this expression, for example, as a question that I'm asking you. Is your grade less than 100 and greater than 90? And you can answer with a yes or no. Is your grade greater than 80? Yes or no, true or false. Now the question is, what if I am asking you a question that the answer is not true and false? For example, how many apples do you have? How many cars do you have? How many courses do you have this semester? You're not going to say yes or false, true or false, or yes or no. You're going to give me a number. And if you have a scenario like that, we have a special case for it. It's called the switch statement. So let's go ahead and show you what is the switch statement. Now, what I'm going to do here, I'm going to say an integer day. And I'll put a day as 1 all the way to 7, assuming Monday is the first day and 7 is Sunday. So sorry, assuming 1 is Monday and 7 is Sunday. I want to convert the day from a number to a word. Okay, so I can totally do that with if statements. That will work. But in a case like that, we have a better scenario. And this scenario is called switch. And what I'm going to do, I'm going to show you the statements, expression of a switch. I'm going to come here and say day. So look here, I start with switch. In this area, I don't have a Boolean expression. Let me just tell you. I'll see a lot of students, they put a Boolean expression here. This should not be a Boolean, it should just be the variable. And by the way, talking about variables, this can only hold integers and characters. No strings are allowed here, no doubles are allowed here. Okay, so we do have 7 main cases. So I'll just go ahead and do that. Case number 1, case number 2, case number 3, case number 4, case number 5, case number 6, case number 7, and then what if it wasn't any of those 7 values? We know for sure days should be one of those 7 values, but what if it was not? We have what we call a default case. A default case basically means if none of those cases matches the day that I have. If that's the case, I'm just going to come here and say cout, just type error, and line semicolon. Okay, so let's go ahead case by case. Case number 1, I'll just say cout Monday, and line semicolon. Okay, now one thing you should understand here also, you just have to add the keyword break here. Why is it important to add the break? So whenever a match is found, you're going to skip the other cases. If you forget this break, you will get errors that result that doesn't make any sense. So what I'm going to do, I'm going to copy this. I'm going to put it here. So Tuesday. Wednesday. Thursday. Friday. Last day of the week. What do we have? Saturday. And Sunday. Okay. So you can see here. Now what's going to happen basically, depending on the value of days, for example, if days was 12, for example, the compiler will compare 12 with those cases. No match, no match, no match, no match, no match, no match, and then the default case is going to be printed error. Now, what if I put the 4? So case 1, no match. Case 2, no match. Case 3, no match. Case 4, match. Show me Thursday and leave that switch statement. So you can see here, this is a case where I do have multiple branches. Depending on a match case, something's going to be executed differently than the other cases. Okay, this is what we mean by switch statement. Now, any switch statement could be converted to a nested if statement, and any nested if statements could be converted to a switch statement. But again, it's your decision to choose which one of them makes more sense to use. I'll give you an example here. If I want to convert this to an if statement, all I'm going to have to do here is to come here and say if day equal 1, then something's going to be printed. Else, if day equal 2. Let me show you, for example. This is going to be printed on screen without the break. And if this is the case, you got the idea. You're going to have to be show me Tuesday and so on. I'm not going to actually write the whole thing. I'm just showing you that you can actually totally convert this switch statement into something like a nested if statement. Now, if I want to convert this nested if statement to a switch statement, it's going to be very, very complicated. And I'm going to show you what do I mean by that. So I'm going to start with switch, and I'll put grade. Look what's going to happen here. Now, look at the first case. What do I have here? I have a case for 100, case for 98.9, case for 98, 97, and so on. So look what I'm going to do here. I'm going to say case 100. And then case 99, case 98, case 97, case 96, case 95, case 94, case 93, and case 92, then case 91, and then case 90. So any of those cases matches, show me A. Now let me put it here. Now look at this. I'm still not done. We go to the other case, 89, and so on. You see what I'm saying here? So let me just save some time. I don't want to actually do that. But I'm just showing you here, no matter what kind of if statement you have or switch statement, you could convert each one of them to the other. Now, the question is, you're going to have to ask yourself this question. Should I go with a nested if statement? Should I go to switch? In this case, obviously, having all these cases By the way, when I put all these cases next to each other, basically means any of those matches show me A. Okay, so if it's 199, any of those matches show me an A. As you can see here, for each one of those, I will have 10 cases here, 10 cases here, which basically doesn't make any sense. So to check for a range of values, it makes more sense to use a nested if statements. And again, this is a case where it's obviously you can use a switch or you can use a nested if statements. It's really not that of a big deal. So this is what we mean by a switch statement. Now, the last part or parts left here to talk about is how do we compare strings? Well, strings is just like any other variables. So for example, string name 1 equal Adam, put semicolon here, lowercase s, string name 2 also Adam, and put semicolon here. Okay, now in C++, it's actually okay to say if name 1 double equal name 2. That statement is acceptable. And how would C++ compare those two strings? It's going to take character by character, character by character, character by character until there is no match. Okay, now you have to remember here it's a case sensitive. So basically Adam here and Adam here are exactly the same, but if I put lowercase Adam, that will not make it the same. So this is how we compare strings. It's also acceptable to say if a string is greater than a string or less than a string, that's also acceptable, or not equal a string, that's also acceptable. But you have to ask yourself this question: how do I compare two strings and say if it's one of them is greater than the other? I'll tell you how. For example, let's imagine this is A and this is A. If I come here and put Z, for example, for some reason, and I'm saying name 1 is greater than name 2, what's going to happen here? This character is going to be compared with this character, and immediately the compiler will see, oh, there's no match here. And then after that, it's going to tell, the compiler is going to ask the question, in the alphabetic order, which one of them comes first? A comes before Z. So basically, the decimal value of A is less than the decimal value of Z. So that basically means this expression is false, it's not acceptable anymore. But if I do it this way, basically I'm saying A is less than Z in the alphabetic order, which basically makes it true. Same thing here. If I come here, for example, put this one as A, and I'll come here and put this as Z. The compiler will compare this character with the character, match, character, character, match, character, character, match. And here's the character that doesn't match. And then it's going to compare the alphabetic order of them. Since Z comes after M, so that basically means this expression is acceptable. Sorry, this string is greater than this string. So this is something you have to think about when you actually compare between strings. What else? I don't know if we talked about that before, but we said one of the primitive data types is Boolean, and I showed you that in before. Boolean, you can store the value of true and false in it. And for example, if you have an expression and you want to store the results of a Boolean expression, for example, 100 equal 100, you can totally do that. Okay, so we compare strings. I talked about short circuit. Now, the last part I'm going to be talking about, and I want you to go ahead and have a look at, well, you know what, let me just do that and I'll be done. As I said, I just need 10 more minutes. We have two parts left to talk about: the characters, operators, and the conditional expression. So I'm going to jump straight to the ZY book and explain them there. Let me start with the conditional expression. Conditional expression is a way to replace a simple nested if statement with one statement here. So let's look here. This is an if statement, and if this condition here is true, this expr1 is going to be assigned to my vr1. If it's false, expr2 is going to be assigned to my VR. Now, what I can do, I can replace this if statement here with something like this. Now, let me show you an example to make it obvious. So I'm going to copy this. Let me go here. Oops. Where is it? Okay. Well, let's look at this if statement here. And I'm going to come here and say integer x equal, let's say 10. And then integer y, semicolon. So I got this here, this expression, a very simple if statement. I can replace this if statement with one simple expression. And that expression is the following: y equal, and I'll put an expression here, x greater than 50. And I put a question mark after that. And then after that, I will put, for example, 50 here, colon, 100, or x, semicolon here. So what does this expression basically means? Y will be assigned to something. That something will rely on the result of the evaluation of this expression. If it happened that x was greater than 50, then assign 50 to y. If it happened that this expression is false, that basically means x is not greater than 50, so x is less than 50, then assign whatever x is to y. And that's what's going on in this expression here. So I can replace those 1, 2, 3, 4, 5, 6 lines with a simple one line. That's what we mean by conditional operators. The last part of the class of today is how do we compare characters. Now, this is extremely important when you process strings. And let me show you that. You can check if a character is an alphabetic character. You can check if a character is a digit. You can check if a character is a space. You can convert a character to an uppercase. You can convert a character to a lowercase. Those functions are available inside a header file called cctype. And they are extremely important whenever you want to process strings. When you have a string, you can have access to each string by itself. And I'm going to show you an example about that. And then after that, you can process that character and do whatever you want to do to it. So let me show you what do we mean by that. Let's go back. Oh, I was talking about those functions here. Is alpha, is digit, is a space, 2 uppercase, 2 lowercase, and all of that will be included in a cctype. So let me just include that header file and show you how does it work. And that will be the last part of the class of today. Okay, so let's go to the string that we have here, which is Adam. Where is Adam? Here's Adam. I want to extract A, for example, here. Now, with Adam here, well, I could come here and say character, I'll call it C, for example, equal name1 dot at 0. So what did I just did here? Remember here, those are the characters of Adam. Each character has a position or location in the string. We start counting from 0. So A is 0, D is 1, A is 2, and M is 3. That's the location of it. So I'm asking the compiler to extract, or not extract, to tell me what is the first character. I can put here the second character if I want. Anyway, I'm just trying to have access to any of those characters. I can come here and say if, I'll say is digit. And I'll put C here. So I'm checking if C is a digit. Well, again, it makes more sense if it's alpha. So I'm comparing C and try to figure out if it's an alpha. Well, and let's put an and here. What else we can do is you can check if it's a lowercase as well. It makes more sense if I check, first of all, if it's alpha, and then after that, I will say if is lowercase. So first of all, I have to make sure if it's an alphabetic character, and then after that, I have to check if it's a lowercase. Remember here, those expressions are going to return Boolean. So basically, if it's an alphabetic character, it's going to be true, and then after that, I'm going to have to check if it's a lowercase. If this is true as well, I need to come here and say cout. I will say to upper, and I'll put C and line to convert it to an uppercase. Now, I want you to think about this. Why it's not a good idea to write two. I'll just put two here. I'll say if, and I'll put them next to each other. Well, actually, it should work. This is actually not a bad idea. Actually, after I'm thinking about this, I'm just going to cut this. I'm just going to put and here. I can take this away. Let me take this away. And let me put this back. Put this here. Okay, so let's look at this one here. This is important to understand. I'm checking if it's an alphabetic character and is a lowercase. Now, at the beginning, I thought that this is not a good idea to put them next to each other, but then I realized because we have the short circuit. So what does that mean? That basically means if this one is false, the compiler will ignore this part. If this part is true, the compiler will continue. Why is this important? Imagine there's no short circuit. So basically, if this is false, it's going to go ahead and try to check if something is not alphabetic character, if it's lower or not. So this should be totally acceptable. So as you can see here, I was able to extract one character from the string. And then after that, I decide to check if it's an alphabetic character and if it's a lowercase. If those both conditions are true, then it's going to convert it to an uppercase. And that will be the last part of the class of today. I am going to stop sharing.